I'm not gonna, I'm not teaching anything, so whatever you want me to go over, I'll go over. So just let me know.
Is it the final exam group problems?
Mm-hmm. Yep. So whatever you want me to go over.
Well, for me, I think I need the most clarification for like inverse problems. So and such inversely. So like this word problem I see, it says the length of the violin string varies inversely as the frequency of its vibration. So I wasn't really getting it, and then I was doing the homework. And I was like, oh, I guess I got it. But then more problems came up. I was like, okay, maybe I don't quite understand.
Mm-hmm.
So
So
yeah,
number 7 is an inverse variation problem. Go ahead.
So where it's k equals such and such. Where are my notes? I remember the variables that I know they didn't really stand for anything specifically, but how it was arranged, I wasn't quite understanding.
That's fine. Let me share my screen.
Okay.
So number 7. The length of a violin string varies inversely as the frequency of its vibrations. If a string is 8 inches long and vibrates at a frequency of 640 cycles per second, what is the frequency of the string that is 10 inches long? So this is an inverse variation problem, basically, is what it is. It says it varies inversely. So it's a comparison of 2 variables: the length of the violin string and the frequency of its vibrations. So the length of the violin string varies inversely the frequency of its vibrations. So the length of the violin string, I could let that be, I could let that be a variable, let it be, I don't know, L, right? The frequency of the vibrations, I could let that be V, right? All right. So these are the 2 variables, right? So what I'm saying here in this sentence, I'm saying L varies inversely. So when we say it varies inversely, that's another way of saying it's inversely proportional. All right. I believe this is in chapter, I forget which chapter these notes take place in. I think it's chapter 2, maybe. I don't know. But anyway, L equals, so when you have when you have an inversely or directly relationship, there's going to be a proportionality constant, right? That's the letter K you're talking about. So that's going to be L equals K. And since it varies inversely, it's going to be over V. So that's the equation that's being described there. Okay. So now I want to find K. I want to find the value of K. So if a string is 8 inches long, so find K when the string is 8 inches long, so L equals 8. And V is 640, right?
Mm-hmm.
So just pop them in and find for K. So what? 8 equals K over 640. Cross multiply there. So what? K equals, what's 640 times 8? 5,120. So my model, the length equals 5,120 over V. My proportionality constant is K, which I just found to be 5,120. Now I could use that to find the frequency of the string that is 10 inches long.
And then you just swap 8 for 10.
Well, now that I have this, right, I could use this to find, now that I found K, I could use that to find the length or the vibration for anything. Like, I could use this to find the vibration or the length of a string given one of them, right? So that's what this says right here. What is the frequency of the string that is 10 inches long? So if L equals 10, what's V?
Oh, I understand. So the frequency wouldn't be the same.
Yeah,
So you need
so
to
this,
use the K
yeah,
value.
I had to have some give information to find K. And now that I found K, I could use that to answer a question, right?
Yeah.
So the question is, what's the vibration and frequency of the string if it's 10 inches long? So that means the length is 10 inches, so that's 10 equals 5,120 over V. Cross multiply. Well, you get 10V equals 5,120 divided by 10. V equals, so that divided by 10 is what, 512? So the frequency of the string that's 10 inches long is 512 cycles per second. That's it.
So then what other, I'm sorry, go ahead.
No, go ahead.
What other problems would we encounter with proportion problems? So inverse varies inversely with means such and such equals K over. Are there different types where it's something K times?
Yeah. Let me go through the notes. Here's all the notes for the whole semester.
Yeah.
You guys hate me, I know it. I think it's chapter 2, but I'll do my best to.
Yeah, it is. I don't know if that helps or not.
Was that Danica?
It is chapter 2. I don't know if that helps or not.
It is.
Yeah. 2.4 something. Yeah, I think so. Yeah, 2.4.
I don't think I have 2.4 with me, but there might be some notes in there that I don't have. But yeah, this is like section 2.4. There's direct variation, there's inverse variation, and then there's joint variation. I'm going to go pour a cup of coffee. It's already brewed. I just got to pour it. But think about what problems you want me to go over. I'll be right back.
Is this the only problem you guys did so far?
Yeah, this is all we did.
Yeah.
Okay. Thank
He's
you.
not gonna go through everything. You have to, whatever you have questions about, he'll go over.
Okay.
Oh, he said he's not going to that.
Oh yeah, that's good stuff. That's what I needed. Elixir.
Can
go
we do? Oh, sorry.
Can we go over number 19? Like all of the parts of 19?
Mm-hmm. And by the way, the videos I made, or I said I was gonna make, I had my laptop up all night so they would upload to YouTube. The process was gonna take like 2 hours. They're uploaded. I just have to attach them to Canvas, and I'll do that. Now that'll take me less than a minute. Or number 19. Now, here's what I'll say. I will give you some tips to study. Even though those videos pertain to information we didn't go over in class, when I do post them in Canvas, I would highly recommend you watch them, okay? Just watch them. I'm not promising that they're gonna be on the final, but just watch them. I just want you to do that, okay? If there is anything from chapter 6 I could put on the final, you said number 19, right, Danica?
Yeah.
If there is anything from chapter 6 I would put on the final, it's solving logarithmic equations, which, hey, look at that, number 19. So some of the, solving some of these equations involves some of the topics in that chapter 6. And I could, I'll go over with that where you're in now. It's really not that bad.
This recording, is it going to automatically be sent to us by email?
Yeah, I'm recording it now. I just have to, once the thing is over, I have to convert it, and then I could put it on Canvas too.
Cool.
That's, I could do that. So, which one, Danica? All of them?
Yeah. Or at least, yeah.
Which one do you want to start? So this one we looked at. We did get a chance to look at something like this in class. Yeah.
Yeah, just all of them. Please.
What about letter E? You know how to do that, don't you?
Well, I mean, okay, I kind of tried starting this on my own. Do I know how to do it? Probably, kind of, but I don't know if I feel so confident about it.
Well, the one that you know how to do, because I showed you in class, is Earl, letter E. All the other ones are pertaining to the videos. So here you could, here you could write these as a common base, right? You could write this as a common base. So this is 5 to the x plus 2 power. Can I write 125 as a base of 5?
Yeah. 5 to the third.
5 to the third power. So there's a property that states if the bases are the same, what else is the same?
The exponents
The exponents. Since the bases are the same, I could say that x plus 2 equals
is
3.
equal to 3.
Subtract 2 from both sides. X equals 1. That's the solution set.
See, but how would you do C? Because it has an E. And
Good
then
question.
7.
Yeah, good question. So this would pertain, so I didn't get to it in class, but in order to solve for this, you would need a property of you need to use the properties of logarithms. All right. That was section 6.5. Now, in order to do this, so I'll write down some of the most useful properties that we use. When you're solving these types of equations, you have to, since they don't have a common base, like this is base 7, this is base E, all right? I'm trying to solve this for x, so I need to get ln, I need to get the x's out of the exponents, all right? So in order to do that, I'm going to take the natural logarithm of both sides. All right, I'm going to take, remember the natural logarithm is base E. I'm going to take the natural logarithm of the left side and the natural logarithm of the right side. All right. Now I'm going to have 7 to the x plus 3 power and e to the x power. Okay. Now there's another property of logarithms that states when you have a logarithm of something raised to a power, you could bring that power out front as a factor.
Are the letters in front of the parentheses ln or log?
That's ln. That's the natural
Okay.
logarithm.
So I took notice, can you move that in front of log or in front of natural log?
No, it comes out front of the natural log.
Right, can you do that with just logarithms too, or is it only with natural log?
Somebody's background is like really, really loud. It's interfering. Sounds like someone has like a TV on or something.
Oh, sorry, I'm at work. I'll mute myself.
Oh, okay. That's all right. So the x plus 3 and the x, they have to come out front as factors.
Yeah, but can you do that also if you had like log rather than ln or?
Yes, that's correct. Yeah, it doesn't matter if it's log or natural log,
Okay.
because the properties for natural log and log log are the same. They apply to, they're the same. So
then what's the difference between them?
what's the difference between them? So that's because we didn't get far enough. So log of base A, that's when of x, right? That's when you have a to the x power, right? This is the exponential, that's the logarithm. When log it has a base e of x, we don't write it this way. We write it as the ln of x. And that is when you have e to the x power. That's the difference. So basically, the natural logarithm shows up when you have e to the x power, when you're working with base e. log shows up when you have base a. That's the only difference between them.
Okay.
So you're working with natural logarithm when you have base e exponents. You work with other logarithms when you have a base a, like base 2, base 5, base 10, whatever. Now, since ln works just as well as log, You could use ln if you want. And I would suggest you use ln because your calculator could do ln. Your calculator can only do log of base 10. But your calculator could do ln. So I like using typically we use the natural logarithm because it's the most convenient. Is everybody okay?
So is ln, it's just kind of a lazy way of writing log base e to the x, pretty much. It's just a shortened version of it.
Yeah, it's a shorter version of this.
Okay.
We just don't write that though. We write, since this shows up a lot, we have its own name for it. It's called the natural logarithm. That's it. It's a
And is
unique,
that in our, oh, sorry.
it's a unique case, basically. Yeah, it's in the notes. It's on the videos. It's just,
No, I was going to say in the calculator. Is there a LN?
oh, I'm sorry. Yeah, it is. So you can notice how your calculator has log and right above it has 10 to the x power because your calculator treats it as base 10. ln is right below it, and right above that is e to the x.
Oh, okay, I see it. I was looking at the smaller ones.
Yeah, that's fine. So yeah, ln you could use in your calculator, you know, and your calculator could do ln, like ln of whatever. All right, so if I continue with this, I can bring these out front. So I have x plus 3 times the natural log of 7 equals x times the natural log of e. All right, natural log of 7 is just a number. That's all, it's just a number. So I'm going to leave it there. You know, I'm not going to, you know, ln of 7 in your calculator, ln of 7 is that number. It's a decimal, but we don't write it that way. We don't approximate it. We just leave it like natural log of 7. We just leave it that way. Now here's another thing you would learn about properties of exponents. ln of e, how are they related? The natural log of its exponent. If this is the exponent and this is the natural log, how are they related? They're what of each other? They're
Are they inverses of each other?
exactly, they're inverses of each other. So if you take the natural log of e, what happens to them? What happens to them?
Does it cancel?
They cancel out, exactly. So the ln of e, boom, they're gone. So actually they become 1. When you take the ln of e, it becomes 1. When you exponent, when you take e of ln, that also cancels. So I'm left with x plus 3 times natural log of 7 equals x. All right. Now I need to solve this for x. So I'm running out of paper here. Come up here. So this is what I have, right? All right. So this is just x plus 3 times a number. So what can I do here? I'm trying to get the x's on one side and the numbers on the other. So what can I do here to the x plus 3 and the ln of 7? I could distribute it, can I? That ln of 7 is really throwing you off, isn't it?
Yeah.
What about it? It's not like something you've seen before, is it?
No.
No, it isn't. And I understand that. But you just have to realize it's just a number. That's all it is. It's just a number. What if this were number 2? What would you do to the 2 here to solve for x?
Yeah, distribute it.
You just distribute it, wouldn't you? You just distribute it and get the x's, and you know, you do that in your sleep.
So in this case, the x plus 3 and the 7 are the exponents, right?
And there is no more exponents.
Oh, there are. Okay, never mind.
No, I brought them out front right here.
Oh, that's right.
I brought them out as friends factors. So I'm going to distribute the ln of 7 to the x and the 3. So I'm going to have natural log of 7 times x plus 3 times the natural log of 7. And that equals x. This is just a number, natural log of 7 times x, plus another number. That's all it is. 3 times the natural log of 7. That's just a number, but we leave it in exact form, which is what this is. You know, what number is it? Use your calculator. You know, if you're curious, you could see it in, you know, just type in 3 ln of 7. It's 5.8, blah, 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 blah. But we don't, you know, we just leave it as 3 ln of 7. All right, I want to get the x's on the left. So I'm going to subtract x from both sides. And then I'm going to subtract 3 natural log of 7 from both sides. X's cancel on the right. So now I have natural log of 7 times x. They cancel, right? Minus x equals -3 times the natural log of 7. Everybody see what I'm doing here? I'm just getting the x's on one side. I'm getting the numbers on the other side. Because what do they have in common now? They have a GCF of what? What do they have in common? This is a number times x minus x. They have what in common? If I wrote this, what do they have in common? This is, you know, you could think of this equation like this. All right? That makes sense to you. This doesn't. It's just a number times x minus an x equals a number equals a number. How would you solve that equation? What would you do?
Wouldn't those the x's cancel out before this step? Where you have like ln times x times 7 minus x. Oh, I see. Well, like, wouldn't you have taken that x away from the other one?
This one?
Yeah.
No, this is being multiplied. This is being subtracted. This is ln of 7 times x minus x. I could factor an x out of this. There's a GCF of x here. I could factor that out. So I have ln of 7 minus 1 equals -3 ln of 7 And now I could divide both sides by this number right here. That cancels out. So I'm left with x equals -3 times natural log of 7 over natural log of 7 minus 1. That's just a number. It's an ugly number, but it's a number. You could check it in your calculator. So the numerator of this was what? -3 ln 7. That's the top, right? Divided by parenthesis ln of 7 minus 1, close parenthesis. So that's the answer. That's what this number is approximately equal to. This number is approximately equal to -6.1715 ... All right, but we just leave it as this big ugly fraction because that's the exact form. I'm going to store that into x. So store that into x. Now I'm going to type in the original equation on both sides. So here's the original equation. So type 7 to the power of x plus 3. When I hit enter, I get that. And now when I type the right side, e to the x, so second ln to the x, I should get the same thing. And I do. So that is my solution.
Are we able to go over problem 18? Well, not the whole thing, at least with verifying it. That's confusing to me.
Sure. So that's the solution set of this problem. It's -3 ln of 7 over ln of 7 minus 1. Before we do that, though, Emily, we have these 3 other ones here.
Oh, sorry about that. I didn't.
Oh, that's all right.
forgot what the
Fine.
3 were.
So letter A. So here's a question. What's the base here? What's the base of this log?
X?
Is it 10?
It's 10. Now it's not base x. It's not base. Where'd you get x from, Leah?
Because I thought you were referring to X plus X.
No, that's the expression that goes into the function. That's the expression that goes into log.
Okay.
The
That makes
base
sense.
is the subscript that you would see right here. Now, like in letter B, the subscript is 2, so that's a base of 2. Now, when you don't see a subscript for log, that means it's base 10. All right?
All right, thank you.
Yep. So I could use another property of logarithms where if the logs of some base of an expression equals the log of the same base of another expression, if the logs are the same, right, and these are equal to each other, then I could say m is equal to n. That's a property right there.
So it's just x squared plus 3 is that equal to x plus 6?
Correct, because these logs at the same bases are you know, since they're the same and these are equal to each other, then I could say x squared plus 3 equals x plus 6. So you know how to solve that equation. X squared minus x minus 3 equals 0. It's a quadratic, so factor it. So what? X and x, 1 and 3. Huh. Really? I did that to you, did I? I don't think you can factor that, can you? No, you can't. I gave you an unfactorable quadratic. Oh, I a stickler. So how would you, what could we use then? Yeah, the factors of, 1 and 3 isn't going to work. And since they're the only factors of 3, I'm not going to get negative 1x, am I? So what am I going to use? I'm not going to factor it, but, you know, it's worth a shot to try and factor it. But now what am I going to do?
You can either put it into a quadratic equation or you can do the AC grouping method, I think.
Well, you can't factor it. You can't use the AC method. We just
Right.
determined you can't factor it.
I guess the quadratic equation, then that's the only thing.
Yeah, the quadratic formula. Yeah. So A here is 1. B here is negative 1. C here is negative 3. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So what? 1 plus or minus the square root of 1 minus 4 times 1 times negative 3 all over 2. 1 plus or minus what? So that's going to be negative 4 times 1 times negative, that's positive 12, right? So 1 plus 12 is 13, all over 2. So my solutions here are going to be 1/2 plus or minus the square root of 13 over 2. Those are my two solutions to that quadratic. So I could check them, right? So let me check it. Now, here's the thing. Well, I could use log of base 10 in the calculator, so that's nice. So let me type in these solutions. So parenthesis 1 plus the square root of 13. That's the numerator all over 2. Store that into x. Now I could type in the equation as is because it's log of base 10. And your calculator does that's nice. So I have log of x squared. Oop. No. Plus 3. When I hit enter, I get that. That's the left side. And then when I do log of x plus 6, and I hit enter, I get that. That's the right side. And you can tell that they're equal. So 1/2 plus the square root of 13 over 2, that works. Now let me try the other one. So parenthesis 1 minus the square root of 13. That's the numerator, all over 2. That's the other solution, possibly. Let's store that into x. And let me type in the left side again. So second enter, second enter, second enter, second enter. There's the left side. That gives me that number. And then the right side, second enter, second enter, second enter, second enter. Here's the right side. Hit enter, and I get that. So both of these numbers work. So my solution set to this equation are the values 1/2 plus or minus the square root of 13 over 2. I won't, I'll say this. My review packet is intentionally hard. So if you could do this, in my opinion, I think you'll be okay for the final. If I could give you some reassurance. It's all part of my evil genius plan to make this review hard so that when it comes time for the race, you're prepared. If practice is hard, you go play the game, it should be a cakewalk. At least that's what I hope. Let me look at letter B here. So this is in the section that deals with solving logarithmic equations. So there's another property here that I want to talk about. So if you have a log of some base where the expression is being multiplied, so if you have a log of a product, you could write this as the sum of the logarithms. So you could write this as log of base A of A plus log of base B of B. That's another property right there. This is called the log of the product equals the sum of the logs. Now, I do mention this in the video, but you cannot break apart a sum of logs, okay? You cannot do that. Yeah, no problem, Cade. So don't do this. Don't do this. Log of some base of A plus B. Don't distribute the logarithm like this. All right. Don't write this as log of base A of A plus log of base A of B. You can't do that. That's not that's illegal algebra. Okay? And don't distribute the logarithm to a sum or difference. You can't do that. The only time you can break up a logarithm is if you have a product or a quotient. If you have log of A over B, that would be log of A minus log of B. I know I'm kind of going through this a little quickly, but you would use this property to solve this equation. So what I'm going to do here is I'm going to write these two logs as one log. I want to get one log expression when I'm solving these equations, okay? That's a rule of thumb. You want to get one log equation or one log expression on one side. So I'm going to combine these two into one by using this property, all right? So what that's going to look like is going to be log of base 2 of what? What's the expression in here going to be? Equals 3. That's the right side. So using this property, what's the left side going to look like?
Wouldn't you multiply x minus 4 times x plus 4?
That's correct, Annika. Yes, you would. You followed this property correctly. Because, you know, I could go in either direction with this property. That's fine. So this, right, I could go in the opposite order and write this as a log of x minus 4 times x plus 4. So these two logs become one log. So now that I have one logarithm, how am I going to get rid of the logarithm? If I have a log of base 2, what am I going to do to both sides to get rid of it? What's the inverse of log of base 2? You guys can hear me, right?
Do you care if we combine the x minus 4 x plus 4 first?
Yeah, you could do that. That's fine.
Okay.
If whatever's inside the logarithm must stay there, unless you have this or the other property, which I can't write here. I'm out of space, but you can write this as a log of base 2 of, so if you FOIL that out, you're going to get what, x squared minus 16? So how am I going to get, I need to solve for x, right? I need to solve for x, but I can't just take this out of here. I need to get rid of the logarithm. How do I get rid of the logarithm of base 2? What am I going to do to both sides? What do you think? What's the inverse of this right here?
Would you do 2 to the 3rd power?
You're not going to do 2 to the 3rd power. Well, it will be 2 to the 3rd power on the right side, but what am I going to do on the left? Basically, what am I doing? What am I doing to both sides?
Doesn't the 2 go to the 3?
You mean 2 to the 3rd power here?
Yes.
Yes, it does. But what about the left side?
And then the 3 goes to, oh shoot, I lost my notes. Hold on.
I'm going to copy this up.
Do you divide it by log base 2?
No, that doesn't work that way.
Okay.
Don't make up math. You can't do that. You can't divide log base 2 because that's like saying, oh geez, I could hear myself. That's like saying you're dividing both sides by sine or cosine or tangent if you take a trigonometry. You can't just do this. You can't do this, log of base 2 divided by log of base 2, because that's incomplete. You need to have an x here. You need to have something in there. You can't do that. Can't do that. Log base 2 of x squared minus 16 equals 3. That's what I have now, right? So how do I get rid of the log of base 2?
I'm not
What's
sure
the
how to get rid of it. I kind of just, I don't know. I kind of just get rid of it on my own and do 2 to the third, to be really honest. I kind of skip that step, so I'm not sure.
Yeah, well, what's the inverse of log of base A? What's the inverse of it? Right here. What is that?
Would it be 2 to the first? I don't know.
2 to the x power. Yeah, you're going to raise both sides. Basically, you're going to raise both sides with a base of 2. So what you're going to do is you're going to raise the left side. So this is going to be 2 to this power here. Log of base 2 of x squared minus 16. And then you're going to raise the right side. This will be 2 to the third power. I just raised this because this is the inverse of log of base 2. An exponent of base 2 is the inverse of log of base 2. So what happens to the 2 and the log 2? What happens to them?
Cancel.
They cancel out. Does everybody see what I'm doing here?
Making the same base, but why does log 2 get canceled out?
Because that's the inverse of base 2. Log of base 2 is the inverse of exponent 2 of base 2. They're inverses of each other.
Do you care if we skip that step? I don't know. I just kind of always skip it.
What? No, you can't skip it, Danica. You have to show that.
Okay.
You can't skip that. That's like part of the algebra. You can't just ignore it because you don't understand it.
Well, I don't know. It's not that I don't understand it. It's just that
Yeah.
I'm used to just taking, that's what I was doing all the other night, was just taking log base 2 and just making that 2 to the third right away.
Yeah, but okay, but you can't just ignore the left side.
Okay.
You can't just ignore because what you do to one side of an equation, you have to do to the other. All right, you know that. So I have log of base 2. So to get rid of it, I'm going to exponentiate both sides with a base of 2. So when that happens, the 2 and the log 2 cancel out. The x squared minus 16 just basically becomes a factor. So I'm just going to have x squared minus 16. These basically go away. And this comes out front as a factor. So I have x squared minus 16 equals the right side, which is 2 to the third power. And you know how to solve that. X squared minus 16 equal 2 to the third power is what? 8. Subtract 8 from both sides. Or you could add 16 to both sides. Yeah, I'll do that. I'll add 16 to both sides. X squared equals what?
4.
X squared equals 4.
Oh, x squared is. Oh, I didn't mean to say.
Oh, 16 plus 8. I can't do mental math today. 24. And then x equals plus or minus the square root of 24. Which is what?
It's like it's a decimal, so
Yeah, just leave it as an exact value. What does the square root of 24 reduce to?
it's
6
like
times
4. well, I guess you could round it. It's like 4.90.
Well, 2 square root of 6, right?
Yeah.
6 times 4 is 24. 4 is a perfect square, so the square root of 4 is 2. 2 square root of 6. So check your solutions. Now, checking your solutions for this one might be a little tricky. For this equation right here, because this is log of base 2. All right. This is a log of base 2. And your calculator doesn't do that. So how am I going to check it in my calculator? How are you going to check it in your calculator? We're limited by our calculator.
Didn't you say that you could use like the natural log button?
Well, yeah, you could, but that's not what you could use properties of logarithms, whether they're natural log or log, but my original equation is log of base 2. All right. So I can't just replace it with ln if I feel like it. I can't do that. But there's a conversion formula. It's called the change of base formula, and it's in the notes. It's in the notes. There's a change of base formula. The change of base formula is the following. You have log base a of x equals the natural log of x over the natural log of a. That allows you to convert a log into a natural log, which you can use in your calculator. So my original equation there, if I want to check it in my calculator, right, my original equation was what? This. That was my original equation. So I could rewrite this using the change of base formula as, so the first expression, I could rewrite that as ln of x minus 4 over ln of 2 plus ln of x plus 4 over ln of 2 equals 3. Just by using the change of base formula. Now I could type this into my calculator. I know it's a pain in the butt because your calculator doesn't deal with any other logs of other than base 10, so you have to use the change of base to use it in the calculator. So when I check my solutions to this equation, I got to use this rewritten equation, not this one, because I used the change of base formula. That's what I did. So what were my solutions? Plus or minus 2 square roots of 6, right here. So let me check them. And I'm going to type them in here. All right, and then I'll have my solution set. So two square root of 6. Let me store that into X. Let me type in this. So just be careful when you type this in. So the numerator will be, so parenthesis, ln of x minus 4. That's the numerator. Divided by natural log of 2. So that's that. plus parenthesis ln of x plus 4, close the ln, close the parenthesis, divided by ln of 2. Hey, that gave me 3. Look at that. What's the right side? 3. Da-da-da-da. And then if I check it with negative, if I check it with negative 2 square root of 6, negative 2 second square root of 6, store that into x. And then if I recheck it, I don't have to type it in again. I could just recall it. So second, enter, second, enter, second, enter. That's the first term right there. Enter there. Uh-oh. What happened? What happened? My calculator did what? Can you guys hear me?
It gave you an error.
It gave me an error. So what does that mean about negative 2 square root of 6?
It doesn't work.
It doesn't work. Remember, well, the domain of a natural logarithm is positive numbers. So if I put negative 2 square root of 6 in here, I'm going to get a negative number. I'm going to have the natural log of a negative number. You can't have that. So the only solution that works is positive 2 square roots of 6. That's it. I will do letter D of number 19. Eight minus 2 times e to the negative x equals 4. So I want to get e to the x by itself. I want to get e to the negative x by itself. So I'm going to subtract 8. The 8's cancel. Negative 2 times e to the negative x. 4 minus 8 is negative 4. I'm going to divide both sides by negative 2. Boom, boom. E to the negative x equals negative 4 over negative 2 is 2. How am I going to get this x out of the exponent if I have base e? What should I do to both sides? What's the inverse of e, base e? Exponent. What's the inverse of that?
Natural log.
Correct. Take the natural log. So you could bring the negative x out front as a factor. So you have negative x times ln of e, but ln of e cancel, equals ln of 2. So you're left with negative x equals ln of 2. And you could just multiply both sides by negative 1 or divide by negative 1, same thing. So you get x equals negative times ln of 2.
So every time you take the inverse of natural log, they cancel.
Say that again.
I don't know if that was like the right question. So every time you take the inverse of the natural log, they cancel?
I think you mean to say every time you take the natural log of e.
Okay,
Is that what you meant to say?
sure.
Because I don't understand like what you
Because
were
like in
saying.
the other problem, they
I know
canceled
I
out
know what you're
too.
saying. I know what you're saying, but you're not phrasing it. And I get
Yeah.
that. I get it. But yes, every time you take the natural log of e, it's going to cancel out. Just like
Okay.
over here, I had log of base 2. What's its inverse? Exponent of base 2. What's the inverse of e? That's base e. So the inverse of base e exponent is the natural logarithm. They undo each other.
Okay, thank you.
Mm-hmm. That's how you solve equations, right? You do the opposite operation.
So for one like this, why does it matter if you have, oh, because you can't have a negative x as your, okay, never mind.
So, yeah, check this solution. Check it. So negative ln of 2, store that into x. So that's what the number is approximated. Type in the original equation. So 8 minus 2 second e to the negative x power. Hit enter, I should get 4, and I do. Beautiful. So that's my solution set. My solution set is negative natural log of 2. I think that was all the questions in that number 19, Danica.
Yeah, it was. I kind of want to go over number 18 too.
Didn't Emily have a request before that?
Yeah, I think it was for number.
Yeah, it was 18 as well, but more specifically, like when you are verifying your answer.
Mm-hmm. You gotta use the composite. Yeah.
Yeah, like I had that one for 18, and then I had a couple others.
All right. So you got to find the inverse of that function. So that means you want to find f inverse of x. All right. You want to find f inverse of x. That's what you want to find. So how do we do that? What do you start with? Start with the original equation, the original function. So instead of f of x, I'm going to write y. Y equals 2 over 3x minus 5. What do I do now? What's the next thing I do?
Don't you replace like the x with the y?
Yep, you swap the variables.
Okay.
So y becomes x, and x becomes y. Now you solve for y. So how do you solve for y there? You could cross multiply, right?
Yeah.
So cross multiply, you're going to get what? 2 times 1, so that'd be 2 equals x times the quantity 3y minus 5. Distribute the x here. So you're going to get 2 equals 3xy minus 5x. I'm trying to solve for y here, so I want to bring the 5x to the left. So I'll come up here. Oh, wait a minute, that's going to get in my way. So I'll have 2 plus 5x equals 3xy. And now I can divide both sides by 3x. So I'll get y equals 2 plus 5x over 3x. That's my inverse. Now you could simplify that a little bit to make life a little easier, especially for this part. Right, to do this and this, right? You just ignore that. That looks a little better. We could make life a little easier here because that would make your algebra a little nicer. So I could reduce this, right? I could write this as, I could break this up and write this as 2 over 3x plus what? 5/3. That's a little nicer. So that's my inverse. But now you got to verify it. So you have to do this for the original and the inverse you got. So the algebra you get for that could be a little crazy. It depends on the functions you have. All right. So let's start with this one. So that means I'm taking f inverse and I'm evaluating it at f of x, which is 2 over 3x minus 5. So you plug that into wherever you see an x in the inverse, which will be what? 2 all over 3 times the input plus 5/3. And when you do that, you better get what? You better get x. So simplify this.
Wait, don't you minus 5 again in the bottom?
Minus
In the
where?
denominator. Because
Right
you have
here?
like the 3x minus 5 and you put in the inverse of f as the x. And where did the negative 5 go?
You lost
Did
me.
it just go under there and it just stays there?
You lost me, Emily. I don't know where you are right now. Completely lost me. Where are you?
Well, you're plugging in. Oh, wait, hold on. I think
Oh, wait. No, I see what you're saying. Yeah, I forgot about the minus 5, didn't I?
Yeah.
Yeah, I did. Yeah, you're right. I forgot about this minus 5. So that's going to be that, right?
Yeah.
Plus 5/3. So I got to simplify that whole thing and hope I get x. So 2, let me worry about the denominator here. So let me, 3 times 2, that's going to be 6 over 3x minus 5. And that whole thing is minus 5 plus 5/3. So this is a oh God, my throat. This is a complex rational expression. So I want to get these two to be one fraction down here. All right. So I'm gonna find the least common denominator. All right, this is all over 1. So I'm going to multiply the 5 by 3x minus 5 over 3x minus 5. All right. I'm running out of paper here. So now I have this. So 2 all over. So I could write this over one fraction. So 6 minus the quantity, 5 times 3x minus 5, all over 3x minus 5, plus 5/3. Distribute the -5 here. Six minus, that's going to be minus 15x. -5 times -5 is positive 25. All over 3x minus 5. And this whole thing is being added to 5/3. So 6 plus 15 is what? Or I'm sorry, 6 plus 25 is what? 31. So I have -15x plus 31 all over 3x minus 5 plus 5/3. All right. I don't like the fact that I have a complex fraction in the first term, so I'm going to bring that up and reciprocate it, right? This thing. I'm
You
going to
like
bring that
flip
up.
it and then you times it by 2.
Yeah, I'm going to bring it up to the top and by flipping it, right? So
Okay.
I'll have 2 times 3x minus 5 all over -15x plus 31 plus 5/3. I know the algebra for this could get a little nuts, but you know, this is college algebra. I'm not trying to scare you or anything. I'm just saying, you know, this is what it is. This is college algebra. So distribute the 2 there. So you're going to get 6x
Minus
minus
10.
10 all over -15x plus 31 plus 5/3. Okay. So I think can I factor this fraction? I think I could. I could factor the top anyway.
You can factor the top, yeah.
So 2 times 3x minus 5 all over -15x plus 31 plus 5/3. Now, that's an ugly fraction down there, -15x.
And then you have to times then the other fraction both sides with the -15x plus 31.
Yep. And then you got to, yeah, and I got to multiply this fraction by 3. Right, they have to have the same denominator, right?
Oh. Yeah.
Yeah, they have to have the same denominators. So you got to multiply this one by 3 over 3. You're going to multiply this one by -15x plus 31 over -15x plus 31. So that'll give it 3 times 2 is 6. Decline my phone. So 3 times, I don't know if I'm going to distribute that in right now. Let me just see what I got. Plus x plus 31. They have the same denominators now. So I can write this all over the same denominator. So distribute the 6 here, distribute the 5 here. So 18x minus 30. I hope I get x out of this, let me tell you. 5 times negative 15 is negative 75. X, and 5 times 31, 155. All over what?
All over the bottom, the 3 times negative 15x plus 31.
Yep.
Would you leave it like that? Or would you distribute?
Well, let's combine like terms up top first. So 18x minus 75x is negative 57x. And negative 30 plus 155 is 125. All over 3 times negative 15x plus 31. Jesus. I hope I did my algebra right. How is that going to give me x? It would really suck if I did some algebra wrong.
That would be bad.
It would be bad. Yeah, it would be bad. Because this is getting really long and just ugly. Let me look over this stuff.
I mean, as long as we know how to kind of do a lot of these steps, will you kind of be a little gracious with the points that you give us on our final?
Well, let me say this, Danica. There is no way there's not a chance in hell that I'm going to give you a problem like this.
Okay.
If I would never give you something on the final that would require this amount of crazy work for one problem. That's just ridiculous. Either I think I missed a step, or I did some incorrect algebra somewhere. I'm just looking at what I did. Or don't know. 2 over 3 times 2 over 3x minus 5. Oh, I see what happened. Emily, you screwed me up.
What?
All your fault. It's all your fault, Emily.
No.
Yes, it is. I was right. There is no -5 down here because that's what I put in here.
So you put in there? I
I'm
thought you're
putting,
supposed to. I thought you're
I'm
supposed to
putting-
put that whole quantity in for x. Though.
yeah, here. I'm putting that into the inverse function.
I see what happened.
You see what happened?
Yeah, I do.
I put this into the inverse function, which is 2/3 times this plus 5/3. There's no -5 there.
Oh.
You see what I'm talking about?
No, that's really easy to mess that up.
It is.
That is really easy to mess that up. Oh, okay.
See what I'm saying?
Because
Yeah.
you're not plugging that into the x. Okay. Because
You're
I was
taking
thinking.
this. You're taking this and you're plugging it into the inverse. What's the inverse? 2/3x plus 5/3.
Okay. Because I was thinking you're plugging that into itself. That's
No,
why.
No, that would be this. That would be this one. That would be the other one you had to do. So I was wondering why this algebra was getting a little ugly. Yeah. So yeah, it's all your fault, Emily.
I thought the same thing, so it's okay.
Someone should have held me and told me to stop. Well, anyway, yeah, the algebra. Yeah, so the algebra was based upon an incorrect function, which is why that was getting really freaking ugly.
Okay, but at least the steps then would be the
Yeah,
same.
the steps would.
Still.
Yeah,
But,
the steps would nowhere be that difficult. Like this is all.
yeah.
Yeah, don't even worry about that.
Okay.
And
So
yeah,
at the end, then it would just be what, like,
well,
what would it come out to? So you know that it works.
you're
Like-
supposed to get what? Supposed to
Just
get X.
X?
You're supposed to
X
get
and
X. Yeah.
Okay.
When you do this here, you're supposed to get X. And that's what we verified this one, and then you have to verify that one. So you would take the inverse and plug that into F.
Okay.
So you take the inverse, you plug it into F, and then you take F and you plug it into the inverse. And you should get X in both cases.
Okay.
Can we go over 20 next?
Yeah. Oh, man. I'm really bummed with myself.
What happened to this problem? We're just gonna throw it away.
Well, yeah, the algebra. Yeah, I was like, I should have got on my gut there. Why did that? Like, I knew when this algebra was getting crazy that something was not right. But sometimes you just go with it. Yeah, that -5 should have been there. So you're going to get 2 over. Yeah, actually, this is not bad. You're going to get 2/6 over 3x minus 5. You could take the reciprocal. 2/6 becomes 1/3. So you'll have 1/3 times 3x minus 5. And when you multiply that by 3x minus 5, they're going to cancel out, and the x in the numerator will cancel out. You'll just get x. Yeah. Yeah, the algebra for that will be much, much easier than, but that's right. What number you want to do?
20.
So yeah, I'm taking this sheet and I'm throwing it away. Number 20. So that's using your properties of logarithms. That would be in section 6.5. So you'll want to write that natural logarithm as a sum or difference of logarithms. So that involves using these properties. So here's the big 3 properties that you'll see a lot. So you have the log, of a product equals the sum of the logs. That's ln of A plus ln of B. You have the log of a quotient, so that's A over B. That's equal to ln of A minus ln of B. And another property is where you have the log of something to a power. You already seen this one. If you have the log of something to a power, you can bring the power out front as a factor. And you'll have R times the natural log of M. So those are the like 3 big properties you'll see. So I want to use these properties to write this as a sum and difference of logarithms and express powers as factors. So if this is what I start with, what's the first property I should use? I'm trying to break that down as much as I can, where I just have sums and differences, no products or quotients, and no powers either. So what do I have here? I have the natural log of what?
Wait, since it's a fraction, don't you put it as natural log A minus the natural log B?
Correct. You're going to use that property. So what's it going to look like?
The top minus the bottom, basically.
So the natural log of the top, which is what?
4x to the power 3.
Minus,
X squared minus 3x minus 18.
don't forget the natural log.
Oh, yeah.
Everybody see that? Everybody see how I got from there, point A to point B there?
Yeah.
Yeah.
Okay. I don't I don't want powers. I don't want powers. So how do I get rid of this 3? What do? I use this property, which means I could do what?
Don't you put it in front of the
Yep.
natural logs?
Yep, you have a natural log of stuff to a power, so you can bring that power out front as a factor. So I can write this as 3 times the natural log of 4x. Now I have minus natural log of x squared minus 3x minus 18. Now what?
Don't you do the same thing with the power, that x squared?
Nope, you can't do that. Why can't you do that?
Oh, I don't know.
You don't know.
No.
Maybe because there's another x there?
What's that?
Maybe because there's another x there?
Because I have subtraction in here.
Oh.
Remember what I said, that sums and differences of logarithms don't break up? Think of it like this. Can I break this up like this?
Oh, no.
No, you can't. You can't break that up, can you? You can only break it up if it's a product or a quotient.
Okay,
Right.
so anytime there's addition or subtraction like that within
Ye-
one thing, we can.
Correct. That's correct. When there's addition or subtraction inside a logarithm, they're stuck in there. They're stuck in there. The only way you could break it up is if you have a log of a product or a log of a quotient. Think of it like that. Okay? I could do that here because this was 4 times x. That was a product. That's why I could do it here and not here. Do you see the difference now?
Yeah.
You always sound so upset, Danica. You always sound like you just sound like you got the blues.
I do.
Why? This is fun.
So, okay. I get it. Kind of. I get it enough to go forward, I think.
All right. Well, the first term, can I break this up anymore? Is this a product here? Is this a log of a product? Is it? Yes or no, guys? Yeah, log of 4 times
Yeah.
x. So what can I do? I could do that, right?
Yeah.
I could write that as, so 3, I could write that as times the quantity of ln of what? Tell me, what's that going to look like? Ln of 4 times x, so that's going to be what? Ln of 4, right?
ln of 4 plus ln of x.
Plus ln of x. Right? This right here breaks up to be that. All right, now I have minus ln of this. So how do I break up, how do I reduce this down? How do I already told you that you can't break this up with the ln because I have subtraction in here. So how am I gonna break that up? I can only break this up if this is a product in here. Well, what kind of polynomial is that? It's quadratic. Does it factor?
Yeah.
Let's try it.
6 and 3, I think.
So I'm going to have ln of bracket. So everything in here is going to be 2 factors, right? So what, x and x? Which factors of 18 give me 3?
6 and 3.
6 and 3. So negative 6 and plus 3. So now I have a log of a product now. What can I do? I can rewrite it as what?
ln a plus ln b. So
Correct.
let me just ask a question quick. Are we basically, we're not really solving anything, we're just expanding this.
Yep.
There's no
Okay.
paper towel there.
Yeah, there's no equal sign here.
Yep.
Do you see an equal sign anywhere? Do you see an equal sign anywhere?
No.
So you're not solving for anything, are
Nope.
you? So this will be minus. Now this minus is going to contribute to the whole thing. So that would be minus ln of x minus 7 plus ln of x plus 3. Close the ln off, close off the bracket. Now, if you wanted to, you could distribute the negative here, and you could distribute the 3 here as well if you wanted to. But since everything is a sum or a difference, and there's no power, and all the powers are reduced, that's it. That's it. You could distribute the 3, you could distribute the negative if you wanted to, but that's it.
Can we do problem 11? Yeah, I did have, I think, a couple problems in the beginning that I wasn't quite sure on because it was a while ago and we just need like a quicker review. So
Number 11.
Yeah, I believe it's 11 because I wrote down the numbers that I needed.
I'm good. How are you?
Yes, that one. I am not good with those kind of questions.
You're not good at word problems. All right.
With more so at least volume stuff, it gets me confused. Geometry, I'm terrible at geometry.
Are you going on to trigonometry?
I've taken trig before, and I don't know how I barely passed.
Sine, cosine, tangent, and all that good stuff.
I remember learning it. I don't even remember what it is now.
Are you going on to calculus?
I think statistics after this.
Oh boy.
Yeah. Is that hard?
Statistics is like the cousin of mathematics.
Okay.
They're related, but they're different.
Okay.
Like, you know, college algebra and intermediate algebra, they're like brother and sister.
Mm-hmm.
Statistics is like the cousin.
So
Okay.
will this help us with physics too?
What? College algebra?
No, well, this particular question.
Oh yeah, absolutely. I mean, college algebra is it's the building blocks for calculus and
Everything else. Okay.
yeah. If you're a STEM major, science, technology, engineering, mathematics, yeah, everything you see here, you're gonna see again, I promise.
A lot of the stuff here that we're learning for this class, would I use that a lot in like business or accounting? Because that's what I'm thinking of probably doing.
Absolutely.
Okay.
One of the videos that I'm gonna attach to Canvas, 6.7, is financial models,
Okay.
especially for business applications, like the amount of money that's accumulated in an account, how it
Okay.
gains interest. Yeah. All right, so what this problem is, an open box with a square base is to be made from a square piece of cardboard, 16 inches on a side by cutting out a square from each corner and turning up the sides. Okay, so we have a square or a rectangle, whatever you want. I guess it's a square, but I drew a rectangle, whatever. So it has 16 inches on each side by cutting out a square from each corner. So we cut out a square from each corner. So then what we get is something that looks like this. All right, we get something that looks like that. And then we fold up the flaps and we get a volume. We get like an empty shoebox, basically. We get something that looks like this. We get an empty shoebox. All right, so express the volume on my throat. My throat is sore from talking all semester. Express the volume of the box as a function of its length of the side of the square cut from each corner. So find the volume if a 2-inch square is cut out. All right, so what do we know? So we know that an open box with a square base is to be made from a square piece of cardboard 16 inches on a side. So we know that this length of a side is 16, right? And we know right here, X represents what? The length of a side of a square cut from each corner, right? So we know that the length of each one of these corner cuts is length X, right? I'm trying to find the volume of this shoebox that we make. Now, volume is equal to length times width times height, right? That's the volume of a box or a rectangle. So if this whole side was 16, and the sides of one of these little corners we cut each had a length of X, then what's this right here? What's the length of this?
16 minus 2x?
Correct. That's right. The whole side was 16. I cut out an X from it, and I cut out another X from it. So I cut out two X's from it, right? So if I cut two X's out of 16, this right here, the missing piece will be 16 minus 2X. Does everybody see that? Yeah.
Yeah.
Now, since this is a box, this is a square, right? Even though I didn't draw a square, I drew a rectangle. Both of the sides are the same. So this right here, even though it doesn't look like it, you know, it's not drawn to scale. So that side is also 16 minus 2X. Right? The length, the area of a box is length times width. They're the same things. If it was a rectangle, but it's not, this is a box. So my width of the box is 16 minus 2X. My length of the box is also 16 minus 2X. Now, what's the height of the box? So think about it. If I cut one of these flaps out, right, that were X by X, and I fold it up, then it's going to be a height of what?
4?
Not 4, no.
8?
Not 8. So I cut an X out of here, right? So if I cut something that's X out of a corner of a sheet and then I fold it up, it's going to be X high, right?
Yeah.
Do you see that?
Okay, the outside flap, right? Yeah.
Yeah. If I cut an X out of the corners and then I fold it up, it's going to have a height of X, right?
Yeah.
So now I know the length, width, and height, so I could find my volume as a function of X. So my volume, so it's going to be 16 minus 2X times 16 minus 2X times X. So if you want to, you could FOIL that out. If you want, you don't have to. In this problem, I just say, find the volume if X is what? Find the volume if a 2-inch square is cut out. And since X represents the length of the side of the square cut out, just plug in 2. You could FOIL that if you want to. I'm not going to do that. But so when I plug 2 in there, what do I get? I get what? Use your calculator. 16 minus 2X quantity squared, right, times X. Ignore that number. Just put in 2. 2 stored in X. Now type that in. So second enter. Now when I hit enter, I get 288. So when you cut a 2-inch box, when you cut a 2-inch corner out of each side of the sheet, you're going to get a volume of 288 cubic inches. I know I said my review session goes to 11:30, but I can go a little longer if you want me to. I'm giving my 105 review at 1 o'clock. So that the absolute latest I can go is probably 12:30.
Can we do number 4?
Sure. Everybody okay with that one? Everybody good with that?
Yeah.
You guys are probably overwhelmed right now, aren't you? Don't worry about it.
Yeah, it's a lot.
Yeah, it is. I mean, you know, this is a hard class. You know, this is challenging, especially if you're not so strong in mathematics. I mean, you do have to have a decent skill in math to succeed in this class, but if it's not your strong suit, you know, it can be a little challenging. There's a lot of information. I get it. And I don't expect you to understand things as soon as you see them. You know, that's what studying is for, and practicing homework. All right. You know, I mean, when I took calculus when I was an undergraduate, I didn't understand it when I first saw it. Some of it anyway, I didn't understand it. So I had to, I studied, I worked at it, and then eventually it made more sense. The things I didn't understand. So this is a word problem. Betsy, a recent retiree, requires $6,000 per year in extra income. She has $70,000 to invest and can invest in B-rated bonds paying 17% per year or in a CD paying 7% per year. How much money should be invested in each account to realize exactly $6,000 in interest per year? All right, so this is an investment problem. Remember when we did those word problems, we made a table?
Yeah.
Let's do it now. I'll make a rough table here. Okay. If I need more lines, I'll include them. But so she requires, actually, I do think I'll need one more vertical line. So she's investing in 2 accounts, right? So she's investing in B-rated bonds. And CDs, right? And then there's a total, right? Now, since we're dealing with interest, right, this is going to be a simple interest formula. Do you remember what the simple interest formula was? I equals what? You remember the simple interest formula?
Is it PR?
PR what? You're close.
Or is it more?
PR times T. PRT. So this column right here, that's going to be my interest column. Right? This is what that'll equal. And then these columns will be the principal. So this is P times the rate of investment times the time equals the interest. So now I just got to fill in the table, right? What's my unknown here? What's my unknown value?
X.
Yeah, no kidding. What is my unknown?
The money that should be invested.
Exactly. Good. How much money should be invested in each account? So that's my unknown. So that's going to go where? Principal, right? What does P represent? That's the principal amount. That's the initial amount you invest, right? So I'm going to put X in one of them, all right? I'm going to put X in one of them. I could put it in the B-rated bonds or the CDs, but how do I find the other entry? There's another piece of information in this problem that'll help me, all right? What's the total amount I want to invest between the two accounts? How much does she want to invest altogether?
She has 70,000 to invest.
Correct. She has $70,000 to invest, right? So the total amount, the total principal is 70,000. So if she has a total of $70,000 to invest,
Wouldn't it be 70,000 minus X?
it would be good. And she invests X in one of them, then the difference will be what she invests in the other, which is 70,000 minus X. That's good. So now the rate of interest, all right, what's the rate for B-rated bonds?
17%.
Yep, so write that as a decimal, not as 17, that's gonna be what? 0.17. And then CDs is what? 0.07, right?
Yeah.
How long was the investment? She's doing it for 1 year, right? She's making an investment. She wants to realize how much interest in 1 year. So T is 1. Now, to find the interest for each account, you're just gonna do the columns. You're gonna multiply the columns together. So X times 0.17 times 1 is 0.17X. So the next one's going to be 70,000 minus X times 0.07 times 1. So that'll be a quantity, right? 0.07 times the quantity, 70,000 minus X. I wrote 70,000 incorrectly. Oh, geez. And that's going to, so what's the total, what's the total interest she wants? What's the total interest she wants to generate?
6,000.
$6,000. So my equation comes right here. (0.17x) plus 0.07 times the quantity 70,000 minus X equals 6,000. So from there, it's just a algebra problem. So 0.07 times 70,000 is 4,900 minus 0.07x equals 6,000. So 0.17 minus 0.07 is 0.1. And then I'm going to subtract 4,900 from 6,000. And that's 1100. Divide both sides by 0.1. 1100 divided by 0.1 gives me 11,000 for X. So how much did she invest in B-rated bonds? How much should she invest in B-rated bonds? She invested X amount in B-rated bonds, so how much should she invest there? $11,000. Jesus, telemarketers, man. $11,000. And how much should she invest in CDs?
$70,000 minus 11,000.
Mm-hmm. Which is what? 59,000. That's how much she should invest in both accounts to realize her investment of $6,000. I'm all ears, guys.
Wondering for number 9, I just want to make sure I have this correct. It's like saying determine algebraically whether the function, and it has an x with the 3 is odd, even, or neither. Since it's a 3 and that's an odd number, that's an odd function, correct?
No,
No.
that's not how you verify if it's even or odd.
I think
Okay, how is it they verify again?
You have to do the even or odd tests. So you have to, the degree of 3 means that what you're thinking about, Emily, is this. Since that is a degree of 3, that means the end behavior is oscillated. So that means that, well, since my leading coefficient is positive, that means my end behavior looks like this. One goes down, the other one's going up.
Okay.
That's what that means. If it's odd, right?
Yeah.
That's if the degree is odd. If the degree is even, so if it's x squared, x to the 4th, whatever, then that means both ends would be doing the same thing. They would both be pointing up or they'd both be pointing down.
So that'll make it even then.
So how do we do this? We're determining if the function is even or odd. So remember, the even test is what? You got to show f of x equals what?
Oh, isn't it something with the inverse? I'm not sure.
No, f of x equals f of negative x.
Okay, negative x. That's what it was.
Yep, you got to show that that's equal.
Oh, okay. I think I remember this.
So replace x with negative x, and if it's the same as the original function, then it's even.
Okay. And then what is it when it's odd then?
For odd, you got to show that f at negative x equals -1 times f of x.
Okay, I'm gonna write this down.
I think it's chapter 2 point, I don't know, it might be in chapter 2 or 3, I don't recall.
Yeah, I don't know.
So for the even, it would be like, say we're gonna solve it, it would be negative. Could we just put the whole thing in parentheses to the negative, or is that not how
Yeah,
it works?
that's exactly what you're
except one.
doing.
Oh, okay.
The whole x will be negative, so it'll be negative x quantity cubed. So if I did this, right? Someone's chatting with me. Hold on, let me check the chat. Oh. All right, Danica. Danica left us. So this would be negative x cubed minus 2 times negative x plus 1. So negative x cubed is still negative x cubed, right? Negative 2 times negative x is positive 2x plus 1. Now, this is not the same as the original function. That's not the same. There's a negative out front here.
Which means that it would either be odd or neither then.
Well, you still have to do the test. Don't,
Oh.
yeah. All I know is it's not even. It's
Yeah.
not even. All that determines is that it's not even.
Yeah. So it's probably either then odd or neither then.
Yes, but yeah, exactly. It's either
But then
one.
you got to see.
Yes. So f at negative x, I just did right here. This is f at negative x.
Mhm.
So if I multiply this function by negative 1, that's the right side here. So negative 1 times.
Oh yeah, that's not the same because then the positive one would be negative 1, and that's not the same.
Correct. So when you distribute negative 1, you're going to get negative x cubed plus 2x minus 1. And they're not equal. They're not equal either. The plus 1 and minus 1 are off. So that's not odd. So
that's not.
if it's not even or odd, then it's neither.
All right.
Why do you have negative 1 instead of plus 1?
Right here.
Yeah.
We're talking about right there. When I distribute the negative to everything in here, negative 1 times positive 1 gives me negative 1.
I think. Oh, this was another one that I had. Number 5. I just did not remember how to do it because it's been such a long time.
Okay. Find the equation of a line parallel to blah with the point 3 comma negative 6.
Is it that you use the y minus y1 and then equals m, that one?
That's, yeah, point slope form.
Point slope form? Okay.
So
Thought it was that one.
you got to use the slope of this.
Yeah.
So
3.
I got to put this equation in slope intercept form
Okay.
to determine the slope. So that means you're going to solve that for y. So negative 4y equals negative 3x plus 5. Divide by negative 4. Y equals what? 3/4 x plus 5/4. Now that's not the equation. This just tells me the slope of the equation I want. So this is the slope of the equation I want. So I'm trying to find the equation that's parallel to this one, right?
Mm-hmm.
So what do we know about equations that are parallel in their slope?
They have the same slope.
They have the same slope. So the equation we want has a slope of 3/4 at the point 3 comma negative 6. So you can use y minus y1 equals m times x minus x1. So y minus negative 6 equals 3/4 times x minus 3. Solve for y. So y minus negative 6 is y plus 6. Distribute the 3/4. 3/4 x minus 9/4. Subtract 6 from both sides. y equals 3/4 x. So negative 9/4 minus 6. You can use your calculator. Negative 9/4 minus 6 is negative 8.25, but as a fraction, that is negative 33/4. Boom.
All right, awesome.
When you say solve each equation algebraically, you want us to solve for x, right?
Correct.
Okay.
You're talking about number 1 or number 2?
Yeah, it's number 2, which I could do. I was just making sure that's what you wanted.
Yep. Yeah, I just say that so you don't use your calculator. You could check them with your calculator, but you gotta, some calculators have, well, the TI calculator has solving capabilities, but I don't show that because it's frowned upon.
For number 12, that it says like determine the value of the maximum or the minimum without graphing. Is that you're using that equation? I think this is negative b over 2a, something like that.
Yeah, that's the vertex.
Okay. Is that able to be used for a maximum or a minimum, or is there a different one for like either or?
A vertex applies to a quadratic.
Okay.
Yeah, so you can't use that for any polynomial, just a quadratic.
Just the quadratic. Okay.
Mm-hmm. Yes. Yeah, that equation or that formula, negative b over 2a, comma f at negative b over 2a, is the ordered pair for the vertex of a quadratic equation.
Okay.
And the vertex could either be a maximum or a minimum, depending on the leading coefficient of the quadratic.
Could we do number 22?
Sure. All right, number 22 involves something in the later sections of chapter 6. These are applications of exponential functions. So this is a model of exponential growth and decay. So this involves something we didn't quite see in class, but it's on the videos. I think this is 6.8. It's the last section that I covered. So a 50-gram or milligram sample of radioactive substance decays to 34 milligrams after 30 days. How long will it take for there to be 2 milligrams remaining? All right, so this follows the model. I know we didn't see this in class, but it follows this model. A of t equals a sub 0 times e to the kt power. That's exponential growth or decay. All right. The K is the value K is a number. That's either a growth or a decay factor. If K is positive, it's growing. If K is negative, it's decaying. So what I need to do to answer this question is I need to build my model. All right. So A sub 0 here represents the initial amount. When t equals 0. That's the initial amount of whatever it is I'm looking at. A of t is the amount after t time. So whatever time is, if it's hours, days, weeks, months, whatever. All right, so I need to find k here. I need to find, to make my model, I need to find k. I need to find my growth or decay factor. So what is A of t equal to? What is A sub 0 equal to? And, you know, t is time, obviously. So the initial amount, the amount after some time, and the time. So what is that information? How much of the stuff is there initially?
50?
50, yeah. There's 50 milligrams of radioactive substance. So an A sub 0 is 50. What is my time here?
30 days.
30 days, so T is 30. And what about my, how much is there after, so how much is there after 30 days, right? If I plug 30 into my function, how much is there going to be? Is that problem? Give me that. How much stuff there will be after 30 days? Anybody?
Sorry, could you say that again?
How much stuff is there going to be after 30 days? That's what this represents. This is the amount after some unit of time, all right? What does it say here?
The
It
substance
decays.
decays.
It decays to 34 milligrams after 30 days, right? So after 30 days, the amount is what? 34 milligrams. So if I use my model, I'm trying to find K here. So A of T is equal to 34 equals my initial amount, which is 50, times e to the kt power. So it's what? K times 30, so that'll be 30k power. Now I got to solve that for k. So divide both sides by 50. So 34 over 50, what does that reduce to? Is that an easier fraction? Yep, 17 over 25 equals e to the 30k. How do I get the 30k out of the exponent? Do what to both sides? How do I get rid of e? How do I get rid of E?
The ln.
Mm-hmm. Take the natural log. I could bring the 30K out front. The ln and E will cancel, right? So I'm going to have ln of 17 over 25. So when you bring the 30K out front, the ln and E cancel out, right? So you're just left with 30K on the right. Divide both sides by 30. So your K value is going to be natural log of 17 over 25 divided by 30. Let's see what that is approximate. ln of 17 over 25 divided by 30 gives me negative point. I'll round that out. It's like 4 decimal places, so negative 0.0129. So it's
But
negative. Yeah, go ahead.
On the exam, you want it in the fraction form, though, right?
Well, for K, you can approximate it because
Okay.
when I go into my model, right? My model here is now. I know I'm running out of space here, but my model is now A of T equals. My initial amount was what, 50? So it's going to be 50 times e to the negative 0.0129 times t power. That's my model. If I were to write the exact value in the power there, that would look really ugly. Like if I were to write ln of 17 over 25 divided by 30 in here, that would just look kind of silly. I mean, you could do it, but that just looks nicer that way if I use the approximate value. So that's how I get my model. I got to find K. But how long will it take for there to be 2 milligrams remaining? I have to answer the question. So what do I do with this?
Could you plug 2 into T?
You don't plug 2 into T. You're trying to find T.
That's why you equal 2 to that?
You said it equal to 2. Right? How long? That means you're trying to find T, right? If it's asking for how long, you're trying to find T when there's 2 milligrams. So this function represents how much is left. So you set this equal to 2 and solve for T. That's for question A. So you set this, so it's going to be 50 times e to the negative 0.0129 times t equals 2. Divide both sides by 50. So that'll be e to the negative 0.0129 times t equals 2 over 50 is what, 1 over 25? Let me go back, let me go to the fresh paper here. Actually, I could probably come up here. So what do I do next here?
To the ln.
Take the ln of both sides. ln of e to the negative 0.0129 times t equals ln of 1 over 25. You could bring this power out front as a factor. The ln and e cancel out. negative 0.0129 times t equals natural log of 1/25. And divide both sides by negative 0.0129. So t will equal ln of 1/25, negative 0.0129. What's that going to be approximate to? Because I'm trying to find it, that's how much time it'll take for there to be 2 milligrams. If I started off with 50, how long is it going to take to get from 50 milligrams to 2 milligrams? Type this in your calculator. So ln 1 divided by 25 divided by negative 0.0129. 249.5. So if I round that to the nearest whole number, so 250. So how long will it take for there to be 2 milligrams?
Approximately 250 days.
Yep, 250 days. That's the hardest kind of problem you'll see on your test. Possibly. I don't know yet. I haven't written the final exam, but I'll try to be as fair as possible.
About how many questions will be on the final?
25 plus or minus a few.
Thank you.
Some of them might have multiple parts. I don't know yet. What about letter B? How do you do that? That one's easy. So what do you do here? How much substance will be there in 15 days? So this is selling T is 15, right? So all you have to do is what? Plug that into your model. So A at 15 is 50 times e to the negative 0.0129 times 15. Approximate. You can type that in your calculator. So 50 e to the negative 0.0129 times 15. That gives me 41.203, so 41.2 grams. How are we feeling, guys and gals?
Overwhelmed.
Overwhelmed? Was that
Yeah.
too much? Was that too much for you?
Everything's too much.
Everything's too much. Hear that?
Can you quick review what the absolute value bar is again? Like just in an equation quickly? Because that was a really long time ago as well.
What, you mean like number 2, letter E?
Yeah, I think it's E.
All right, so isolate the absolute value. Isolate it. So just add 4. All right. So you're going to have the absolute value of 4 minus 3x equals 5. And now since this is isolated, I could just break it into two equations. I could say, because it's absolute value, I could say 4 minus 3x equals 5, and 4 minus 3x equals negative 5. And then just solve these two equations. So subtract 4 from both sides. We're going to get 1 divided by, you're going to get x equals negative 1/3. Subtract 4 from both sides. Negative 9 divided by negative 3. X equals 3. Now you got to check these.
Okay.
So negative 1/3, store an x, type in the original. So math, absolute value, 4 minus 3x minus 4. That gives me 1. And then 3. Second enter, and that gives me 1. So they both work. Anything else? Are we okay? I mean, all things considering,
Hopefully.
hopefully. Um,
Are there going to be a lot of other questions on the test that are not like those?
that are not on here,
Yeah.
possibly.
Okay.
That is a possibility. Just because it's not on here doesn't mean I won't ask it.
Mhm.
But you know, I'm not a jerk. You know, I'm not gonna. You know, I'm not gonna give you something that I've only showed you like. You know, I'm fair.
Okay.
I'm a fair person. I'm a fair professor. I'm not gonna do anything skeevy. Are we okay? There's only two of you here. Everybody else they couldn't handle it.
Yeah, I think that's all, at least for me.
Yeah, well, I mean, you know, between now and Monday, I do have, you know, I will be available if you have any questions. I'll just be grading stuff and writing my test.
Okay.
So I will be around.
Are there certain days that are better for you if I needed help again?
Well, I'll be around Sunday most of the day.
Okay.
Sunday's a pretty chill day for me. Tomorrow, well, either this evening or tomorrow, I may not be here for a little bit.
Okay, good. That works. Yeah, because I have work tomorrow, so I wouldn't be able to.
But it won't be long. But Sunday's more laid back. So if you have any last minute questions,
Okay.
I will be around Sunday. You know, if I can just give you some suggestions to study, you know, just focus mostly on the stuff we did cover in class. I do want you to watch the videos that I put on Canvas, and some of the things that we looked at today were in those videos.
Okay.
You know, I'm going to try and be as fair as possible. Yeah, so that's all I got, really.
All right. All right. Thank you.
You're welcome. Yep,
Have a good day.
you too.